get into the big topic of open source, something that we actually say at Red Hat.
We have a
This is so
we
awesome.
are an open culture that believes
actually
in
a big
employee
piece
What is that process that a developer, or let's say a
As the
developer
Kubernetes ecosystem really boomed,
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. As always, a mouthful, and I am Andrew Sullivan, the co-host of the stream, and as always, joined by Johnny. Johnny, happy Wednesday.
Happy Wednesday, my friend. How are you?
Still vertical, so I can't complain too much. It's another great Red Hat day, and that always makes a difference.
That's right. How's the weather out there? Like the weather here in San Antonio it's a little chilly right now, but it's gonna be like 82 today, nice and sunny.
It's gray. It's that time of year.
Okay.
Yeah. So it last week it was so funny because it was like Tuesday through Friday was just all gray all the time. And for me, like I'm one of those people who I wake up best like with the blinds open, right? And just let the light do its thing. And I wake up and I feel, I don't feel groggy or anything like that. So all week last week I was struggling to get up at my normal time, which is usually like 7:15 in the morning. And then Saturday morning, it's bright and sunny out. And of course, it's like, so immediately first thing in the morning, I'm awake. And then Sunday, of course, we had the time change. So yeah, it's been fun.
Ruined everything.
Yeah. So glad that you're having good weather though.
Oh yeah.
So hello, Khalid. Thank you for joining us again. Nice to see you this week. And hello to everyone else in our audience. So we are excited to be here. I'm happy to welcome one of my peers in the technical marketing team, and that is Ortwin Schneider. So today's topic is the Red Hat OpenShift Service Mesh. This is something that we've had on our calendar for a long time, and Ortwin happens to be one of the top subject matter experts inside of Red Hat. So very happy to have you join us, Ortwin. Sorry, I just realized that I closed that as you were taking a drink of coffee.
Thank you for having me here.
So yeah, it's this is one I'm looking forward to because if I'm being honest, I really don't know much about service mesh. Like I can tell you kind of what the purpose is and kind of the components, but that's about it. So this will be an interesting one.
Yeah, I mean, I have to honestly admit that I'm not sure if I'm right here. So this is Ask an OpenShift Admin. So to be honest, I'm more a developer. So at least my background is more development. So I thought I could ask you some silly questions about service mesh, at least at the infra level. No, I'm just kidding. So
we'll learn together. What's the worst that happens?
This is going to be amazing.
No, I hope for interesting, discussions. And I think service mesh is for both, right? So this is for there are aspects for developers. There are a lot of platform aspects, but just to mention, I'm also not that deep in the infra side, so I'm more from the developer perspective. And I'm really interested in the audience today. So what is the experience really like? How are they using, and how is the separation of how they use the service mesh? Like what the ops people are doing, what dev people are doing, where's the handover, things like this. Because there's a lot of discussion, confusion everywhere around it, right? So yeah.
Yeah, and it's interesting that you bring that up. So I'll use that as a segue into our top of mind topics, and I'm going to surprise both Johnny and Stephanie behind the scenes by adding one at the very last second. Actually, Johnny already kind of knows about this one. So let me share my screen here. I want to share this guy. And the first thing that I'm going to bring up here is actually a blog post that Johnny and I, we discussed inviting the author here, Christina, onto the Ask an OpenShift Admin. And I think this is a really interesting topic and very much in line with what Ortwin just brought up, right? Which is, hey, we're not creating, deploying, managing, we're not doing this job as an OpenShift administrator for ourselves. We're doing it for the applications. We're doing it for the development teams. And I thought this blog post was really interesting because it very much takes the same approach that we try to here, which is, hey, reach out and talk to those folks. Find out what they find out what they're doing so that, you can work together so that you can figure out the best solutions for all the things that are going on. So I would definitely encourage you to check out the post, read through it. Again, we'll reach out. We'll see if we can get them to join, and we can have a conversation about it and all of that. Let me post the link here. Yes, I want to watch now Twitch. I want to watch myself. That's not strange at all.
Yeah, she did a really good job of breaking it down, right? And really like simplifying, not really a complex process, but just like complex conversations with customers, And I think she did an awesome job on that.
Yeah, and it's something, even I sometimes forget, who the customer is when you're an administrator, which is those app teams, those developer teams. And, last week we were talking about BGP, right? And, hey, go talk to your network admins, go, buy them coffee, go bring them donuts or bagels or something and make friends. The same thing with storage teams and, so on and so forth. If you're not the virtualization admin, the same thing with the virtualization team, on and on and on. So yeah, it's important to remember that and to, of course, build bridges, so to speak.
Yeah, for sure, for sure. It's all about the so what to everybody, right? Like because everybody matters at this point.
Yep, exactly. Okay, so after my little surprise there, let's talk about a couple of other things. So first, we were a little bit mum about it because we kind of had to be, but OpenShift 4.10 is GA. It is fully released. It actually, I think the bits hit the mirror like maybe 20 minutes after we went off stream last week. So they we knew it was in the process, but it also, that process takes something like 12 hours. So we didn't know when it would actually go out, and I didn't want to, I didn't want to spoil it or otherwise cause frustration or anything if something happened at the last minute that caused that to get delayed. So, surprise, OpenShift 4.10 is GA. And if you would like to upgrade today, you can switch to the fast channel and you can do that. OpenShift 4.9 to 4.10 upgrades are available. Remember, fast channel is fully supported. So if you encounter any issues, you can pick up the phone and call us and we'll help. But stable will take a little bit of time. So we usually talk about this with every new release of OpenShift, where it takes somewhere between 45 and 60 days for a new release to reach the stable upgrade channel. But remember, that doesn't mean that new deployments with OpenShift 4.10 or upgrades in the fast channel, they're both still fully supported, generally available, so on and so forth. RHOPE 9, apart from being able to enforce security within the cluster, enables tracing, helps focus on the right components. Yep. Yeah. RHOPE 9. I know this is a topic that you've been looking forward to in particular for a long time. So I know you're excited to have Ortwin on and be able to ask those questions and talk about it. Yep. Switched back to stable 410. Yes, that is a good option and a good reminder. So as RHOPE 9 pointed out there in his last comment, so you can switch to the fast channel to do your 4.9 to 4.10 update, and then switch back to 4.10 stable, right? And that's a fully supported process as well. And then you'll pick up only the stable, releases for 4.10 after that. Depending on how many using already right now, that is, or for it to become stable. So the precise process that they use to decide when to go from fast to stable, or even candidate to stable, is unknown to me. And every time I ask engineering, they kind of give me this weird look like, why do you want to know that? You don't need to know that. Just trust us when we do it. So what I know is effectively it is based on a number of things. So one, of course, is how many times people have gone through the upgrade process, right? So yes, some of it is based on simply, people going through the update and all of that other stuff and seeing if there are any problems, right? How many tickets were opened? How many BZs have been found? What are the severity of those BZs? And so on and so forth. And, it isn't solely dependent on that because, of course, in the background, the CI systems, the engineering folks are constantly doing upgrades as well. Like literally CI is every moment of every day is burning through different deployments and upgrade scenarios and all of that. So it's really a confidence thing that it is going to work with minimal issues for the widest set of folks is when they make that decision. Let's see. What's next? Oh, good. Another CVE. So last week we talked about a CVE, and now which one is escaping me, and I don't have that note stock up. I did check it before we started the stream today, and I did not see any updates since last week. But there was a CVE that was recently announced, or released rather, and it is 2022-25636. I'll go ahead and paste this link over into Twitch. So this one is it seems to me to be a fairly severe one, right? It is a 4.7 on the impact score here. One thing to note here, and Johnny, please correct me if you have anything to add. So one, as we see down here, RHEL 8 is affected, right? So remember, CoreOS is at RHEL 8, so CoreOS and OpenShift will also be affected with this. So please do keep an eye on the update channels for whatever ZStream or the ZStreams for whatever Y release you happen to be using. But you'll notice that the main mitigation here is to turn off user namespaces. And there is a very handy note here that says, well, if you're using containers, you can't turn off user namespaces. Well, of course, OpenShift uses containers. So the mitigation here doesn't apply. I don't have any further details or information on that at the moment. I'll continue to keep an eye on it. If you have any questions, feel free to reach out through the various, usual ways. Twitter, Reddit, Kubernetes, Slack. There's an OpenShift users channel in Kubernetes Slack, so you can always reach out and ask for clarification or ask for questions, and of course, email andrew.sullivan@redhat.com. But that's all I know for now. Johnny, do you have anything?
No, that covers it.
Okay.
And
Yeah,
so, I'm sorry. I was going to say in the link or in the chat, I put the CVE for last week, the dirty pipe. There is a fix for RHEL 8, so it came out. It was released March 10th. Sorry about that. Didn't mean to cut you off.
No worries. Thank you for posting that because I did not see that. So usually what that means is, let me think from the last time this happened. It takes somewhere between 1 and 4 weeks for a RHEL patch to make it into CoreOS, to make it into OpenShift, depending on all of the things that are going on, so on and so forth. So again, keep an eye on the ZStreams that are released. Keep an eye on the release notes for each one of those to see which ones it is patching and affecting. Next up, a quick one. So Sandbox Containers, which you remember we talked about in episode 50 with Adele Zaluk. So Sandbox Containers are now generally available. Yay! So if you happen to be using or have a use case for Sandbox Containers, remember that is a fully isolated container, right? It basically uses KVM, right, virtualization to create a fully sandbox, fully isolated container instance, separate kernel and everything inside of there. So maybe important for some security, high security type scenarios, various other things where it is untrusted code that you're running inside of there. So yeah, be sure to check that out if it's interesting to you. And I've got a link to episode 50 here. I'll just copy that in. Oops, wrong window. So I'll post the YouTube link there for episode 50 if you want to go back and review Sandbox Containers. Let's see, two quick ones left. Johnny, Podman 4.
Yep. So Podman 4, we talked about it last week where Podman 4 was released and there's a bunch of support, but I was going back through the blog and I saw that Podman 4 is not going to be released on Fedora 35. It introduces a breaking change on Fedora, and Fedora has a long-standing process of if there's a breaking change, they won't allow it to be released. So if you're using Podman 30, or back up, if you're using Fedora 35 and you want to upgrade to Podman 4, you cannot. It won't be part of their. It won't be available. And then there's another release today, 4.0.2. And that gives, if you're a Mac user and you're using Podman, then it allows for volume access. So where you can now run like Podman run with -- volumes, and you can mount your Mac volume into your container.
Very cool. Yeah, I have to admit that I use Podman, but I use it like in VMs and stuff like that. To run things like I don't know, like a web server and stuff like that. I don't use it often on my laptop, and definitely not on my Mac laptop.
Yeah, I hardly ever use it on a Mac. I mean, I'll do it just to kind of like tinker with it, but generally I'm the same way as you. I'll run it on my Linux machine and go from there.
All right, so last but not least, I'm going to switch the window that I'm sharing here over to my terminal. And so this one came from somebody internally asked, hey, what are all of the OpenShift star namespaces? What does each one of those do? And there is no documentation, right, or nothing that I'm aware of in the docs that says, hey, OpenShift API server is this, or hey, OpenShift storage is this, and so on and so forth. So there is a command, and am I sharing this? Yes, I'm sharing this. So if we share that terminal window, there we go. So there's a command that you can use in order to see basically all of those things. So if I do an OC-get cluster operator, OC-get CO, I have this whole list of cluster operators running in my cluster, and you can see I'm running 4.10.3 here, which is the GA release. And for each one of these, I can basically identify which namespaces are assigned to it or used by it, and some other information just by doing a describe on the cluster operator. So if I do OC-get, use that random, we'll go with machine API. And I want describe, not get. It helps if I tell it the resource type. Okay, so down here at the bottom, we have a related objects section. And then you see here, I've got like a namespace and machine sets, roles, cluster roles. So this one only has one namespace, and it happens to be OpenShift Machine API. So that's the first hint that, if I'm looking at OC get project and OpenShift, right? So I've got this huge list of system level namespaces. So that's the first indication of, hey, OpenShift Machine API is owned by, well, the machine operator. So what if I want to find out more information about that? So there's a command, ocadm release and info, and it gives me a whole bunch of information about the particular release that I'm using. And you can see in this big list here is all of my cluster operators, right? All of the images that are associated with it. So that alone is somewhat useful, but what's really useful is if we use the --commit -urls option. Helps if I spell it correctly. And here we now get the GitHub repo link for each one of these operators. So machine API operator, for example, we can see here, I can find in github.com/OpenShift/machine API operator. And I can go there and I can now find out a whole bunch of information about that operator and what it manages. And, usually the devs are really good about including things like how to troubleshoot or how to get more information. If you feel like reading Go code, you can certainly dig in and see what's going on inside of there. So I thought that was an interesting one. I think we talked about this like way back in the early days of the stream. I want to say like somewhere in before episode 10. So it's been a while since I looked at this command. The last time I did it, there was maybe 30 of these, and now there's, well, a lot.
Yeah.
And so yeah, interesting bit of information, interesting way to kind of find out how to really dig deep into particular operators or particular functionality.
Yeah, I didn't even know about that. That's an awesome command.
So yeah, I don't remember how I found that out. It was either from engineering or for support. It might have been somebody like Eric Rich on the support side who told me that one.
Yeah, that's pretty awesome.
This is really cool, really cool. And again, learn something. I think I should see this show more often.
But we always welcome new audience, Orwin. Always. All right, I'll stop sharing now. That's all the top of mind topics we had for today. So yeah, let's talk about service mesh. And I don't want to steal your thunder or anything like that. I think you had some slides prepared, Orwin, and I have to say I love your title slide and the prettiness of it, if you will. So I won't spoil anything by asking you any pre-questions. I'll let you tell us about service mesh.
Yeah. Thanks, Andrew. So let me just share my screen. I think I have way too much slides. So this is just kind of things we could talk about and discuss, but let's see how far we get. And also really, if there are questions out there or things to discuss, yeah, feel free to ask. So let me share my screen and yeah, give me a ping something.
Good to go.
Okay, great. Yeah. So yeah, today, as mentioned, I mean, OpenShift service mesh and service meshes in general, they are quite, I mean, this is a very, how to say, extensive topic, right? So some people say service meshes are as complex as Kubernetes itself. So that's why also there is some, I would say, some restraint out there in the community, and the adoption of service meshes really isn't that high compared to other, let's say, technologies. And yeah, this is for a reason. And today, what I would like to do is to kind of talk about service meshes more on the introductory level to give especially administrators kind of the awareness what it is and why in the world would I need it at all, and do we have some specific, or is there a specific kind of workload characteristic where it makes sense, or where it is appropriate, where not? Who is using service meshes at all? If I decide to introduce a service mesh, so who are the personas using it? I have developers, I have different types of platform, let's say, responsibilities and so on. So, and then of course we all kind of know that it is kind of a platform service. So there is an additional service on top of the actual platform. So there is a kind of overhead. So what is the overhead, right? And this is also a concern for many customers, so to say. So basically what I wanted to talk today is kind of, like a 360-degree brief overview on service mesh. So basically covering what is it in general? What is a service mesh? Why do I need it? What are key features and capabilities and very typical usage scenarios of a service mesh? Then have a look at the OpenShift service mesh, and how can you get it? Do you need to buy it? And how to install and things like this. Considering then a little bit the different types of applications, where is it appropriate or not? Probably what is considered there. As mentioned, the personas and users, overhead, a little bit. I've prepared a demo for Mesh Federation. This is a new feature in our recent or the latest release of Service Mesh 2.1. So there we introduced the Mesh Federation feature. So there's a demo out there, so we could have a look. And just I haven't installed it. My plan would be to deploy together with you and see if my scripts and everything works out. So and then also like FAQ and roadmap items. I think there's way too much stuff, but this is general, at least my preparation and plan for today. So
okay, yeah, this is perfect because I can spell service mesh, and I know that there's Istio involved in there somewhere, and I think Jaeger, and that's that. We've now reached the extent of my knowledge, so I'll let you move on ahead. And for our audience, for anybody who's watching us, please help us prioritize. If there's things that are interesting to you that you would like to see or like to know, please feel free to ask us in chat. So whatever platform you're on, so it doesn't matter if it's YouTube or Twitch or anything like that, all the chat gets accumulated and rebroadcast to all of them. So don't hesitate to post those questions.
Yep, and Ortwin, I'm sure you're going to get to it, but Khalid did have a question, like when he should or shouldn't use the service mesh. So kind of keep that in mind as you're talking through some of these things. Like maybe you can, as you're going through your list, right, kind of like associate that.
Yeah, we can definitely address it in certain aspects. Yeah. And as mentioned, the whole topic is very, let's say, complex, extensive. So if there is kind of, in the audience, there are specific interests in certain topics, like whatever, distributed tracing and so on. So that could be something where we could create kind of a follow-up also in a session, because there is a lot in every aspect. We could really go deep dive into some things. So this is really a generic overview to really get the awareness and context and just the understanding of what it is in general. But there is much, much more than what I've covered today, right? So Yeah, just to let you know. So then let us begin with the very basic question. So if you really don't know what it is, the question, what in the world is a service mesh? And if I would need to answer it in kind of one sentence, I would say this is a programmable network. So it's kind of an overlay on top of what's in OpenShift, the SDN. And basically, you can reduce it to a service mesh is, I mean, there are different implementations out there in the market, so there is Istio, there is Linkerd, and so on. But basically, they all work the same way. So you have a bunch of user space proxies sitting most of the time as a sidecar container next to your actual services. So this is kind of, you have a bunch of proxies, and of course, you have a control plane. So you have some management processes and components with which you actually manage your proxies, and they provide certain APIs for the proxy. So normally the proxies will kind of access the management components to get some informations or to send some metrics to the control plane. But also you have several APIs to be able to kind of configure the proxies out there. So if you reduce it to this is what a service mesh is. So it is user proxies and it is a control plane. And what the proxies do is they intercept the calls. So every traffic going to a certain service, they intercept it and they do something with it, right? And normally, so the feature set depends on really the proxy you use. So depending on the service mesh implementation, you could use different type of proxies. Normally you have, or we're talking about TCP layer 7 aware proxies, and for inbound and outbound messaging. So they act as proxies and reverse proxies. And so the focus is really on the inter-service communication. And this is kind of also or I would say that differentiates from API management or API gateway solutions. So they're more focusing on ingress traffic to APIs, where service mesh is more the focus on inter-service communication in a, let's say, trusted environment. Yeah, so basically, this is what it is. So the control plane has certain capabilities like different types of service discovery, TLS certificate issuing, and a lot more like metrics aggregation and so on. But this is basically what it is. So this is just from the Istio page here, the architecture. So you see there's the data plane. So all the proxies we have in our environment, they kind of form the data plane. And this is where the actual traffic goes through and where we apply our configuration, some routing stuff, load balancing, whatever the proxy is capable of doing. And so the communication is kind of from proxy to service and from proxy to proxy and so on. And we can do a lot of nice fancy stuff with it. But if you think about it, okay, we have now like 1,000 services in our environment, and if we add like a sidecar for every service, it sounds like a lot of overhead. And so when you think about proxy requirements, of course they should be very fast, the proxies, because you're also adding latency, of course. So you add additional 2 hops to every call, right? So on the client and server side. So you add latency. The proxies definitely consume CPU and memory, and also you need to maintain and configure all these proxies out there. So these are the things to consider, and this is somewhat or I would say some especially if you consider to use a service mesh, a lot of customers are afraid of doing it because of these reasons. So
it's important to think about, right? Because it can't get that information, magically. It's we're not doing like a IP capture, right? A network capture, for every one of these things that's going across. Rather, they get proxied, and the proxy does the analysis and reports back that information to the control plane. and that's how we get visibility into what's going on with the application and the things that it's doing. So yes, there is overhead, and it comes down to balancing that value versus cost.
Exactly. So the question is now, if you decide, okay, I'm installing a service mesh, let's go for it. So all of a sudden you have to kind of manage like hundreds, thousands of proxies, and is it worth doing it, right? So this is the question, and I would say there are different aspects to the answer. It's worth doing it. So the first thing I would say is one thing to consider is really the operational cost of deploying. And this is really reduced to, for example, by using Kubernetes, by using OpenShift Service Mesh, the way you manage the proxies you deploy and bring them, let's say, into life, right? So this is one thing to consider. But the actually more important thing is that you could really add additional logic to your existing services, to your existing ecosystem, and really capabilities which are vital, especially for, let's say, a more or a bigger microservice architecture. And you can do that without changing the ecosystem in any way, right? So, and this is very important, that you can add all of the capabilities without changing the service itself. So this is what makes it worth the most of the time, at least. So you have to consider a lot of other things, but basically, I would say these are the benefits of a service mesh.
And a quick question from Waleed. Can we use service mesh for cluster level ingress, or is it only for pod-to-pod communications?
Yeah, you have in general, like you see here, you have Envoy proxy. So our OpenShift service mesh is based on Istio, and Istio uses Envoy proxies at this layer, and they are used as sidecars for the the internal mesh communication. Mm-hmm. And for external communication, we have also kind of Envoy proxies standalone, kind of at the edge for Ingress and Egress. And there's also an integration with OpenShift. So for example, if you configure an Ingress gateway, you would, OpenShift Service Mesh would configure an OpenShift route for you. So there is Ingress and Egress gateways to let traffic into the service mesh and also to go out of the service mesh.
Just to be clear, and a clarifying question from Khalid. So effectively, you can either continue to use the traditional, OpenShift Ingress controller based on HA proxy, or you can use the Envoy-based Ingress proxy for cluster Ingress.
You would use the for cluster Ingress. You would use the combination of OCP routes with the Envoy Istio Ingress.
Okay, so it does replace HA proxy.
Yeah, it is a combination. So HA proxy is for the OCP routes, the implementation, right?
Okay.
And also then the route will forward traffic to the Envoy proxy, to the Istio Ingress Envoy proxy.
Got it. Okay. So it does use both. It's just exactly. A client from outside the cluster coming in will hit HA proxy first, and HA proxy will send it to Envoy, and from there.
That's the way. Yeah.
Now, is that for all services, or is that just for those services that are within the mesh?
No, this is only for the services you want to expose, or they need to be kind of accessible from outside the mesh, right?
Okay, so if I have an application, just call it App A. That's just a standard OpenShift app. It's an OC new app that I just stood up outside of the service mesh. That would still use HA proxy ingress coming in the normal OC routes and stuff like that without using the service mesh at all. But if I had App B that was in the service mesh, it would go through HA proxy and then route down to the Envoy proxy into the mesh.
Yeah, you would have like an let's say normally you would have like an UI service kind of thing, right, for your application. application. And this one is exposed and accessible. So you would configure kind of a gateway component in Istio. And this would kind of translate into an Ingress gateway configuration for the envoy. And also it would create an OCP route to access this UI service from outside the mesh. So from a customer or client perspective, you would then hit this kind of URL. You would go through the Ingress gateway and also then be routed into the mesh to the different services. So the only thing exposed would be this UI service and the necessary paths you need from the client side, right? Every traffic would then stay inside the mesh.
Okay.
Gotcha.
Yep, that makes sense. And audience, please continue to ask questions if there's any confusion.
Yeah, we can see that also later if we come to the demo part, right? So we can see that there is an access from outside and what you see and the communication inside and things like that. Yeah, so that's basically the thing. So it's worth doing it if you have like kind of the right type of applications, the right requirements. It depends on what you want to do. So this is why we should look at what are the key capabilities of a service mesh, right? So what does a service mesh typically offer? So more or less everything which is out there in the market, they have some key capabilities which are around traffic management. This is the way on how you want to route your traffic from outside the mesh to the different services and as well as inside the mesh. So, and what it also includes things like implementing resiliency and reliability, like, for example, configuring retries, configuring things like a circuit breaker to prevent some cascading failures, things like this. And also then load balancing to the target services, so with different strategies. You can have different also release deployment strategy. For example, if you want to do A/B testing, canary deployments, things like this. So there is a way to really granular define all this traffic flow inside a mesh. That's pretty nice and cool. The other thing is observability, and this is also for I would say for application developers very interesting, because if you have really an application which consists of multiple services, and like this service A calls B, C, D, and so on. So you have a lot of service calls, and your request path is quite long through the service mesh. So you need to understand kind of what are the paths your requests go, what services are getting accessed, and also to if there are any issues, if there are latencies, you need to identify these issues. And we all know microservices are distributed. It's a distributed architecture, and to troubleshoot it and help in such situations is quite hard, right? So observability, metrics, tracing is very, very important also to understand what is going on there. So even if you don't need any other features, like you don't want to route anything, you want to kind of apply any security stuff, just the purpose of observability, and also, for example, with Kiali, which is our visualization dashboard, it's worth to have it to really see what's happening in your application, right? So this is one aspect. The other thing, policy enforcement. So there are different types of policies. So we have authentication authorization. So there is a custom resource called authorization policy, for example, and there you can specify, for example, who is allowed to access the service from this specific IP, from this service identity, and so on. So you can really granular define all the authorization policies you need for all the services inside the mesh, and the mesh will enforce these policies and will distribute it among the consumers and so on. So, and the nice thing is, as mentioned, all the things you can do here, so all the features, also applying security, which is nice. I mean, there is an integrated certificate authority coming with Istio. So, and by default, the traffic inside the mesh is always using MTLS when it's possible. This is also one way or you could use a service mesh to kind of facilitate things like zero trust networking with authorization policies, with Kubernetes network policies, and also with the identity and security features that the service mesh offers. So this is a combination of all the three things. And with these combination, you could really do things like zero trust. So
yeah, and I want to point out that there is some overlap with some other OpenShift features, right? So things like network policies, and now it's escaping me. What's the thing, Johnny, where we can turn on SDN encryption between nodes in the cluster? It requires,
You're talking about IPsec?
yeah, IPsec with OVN, right? So one, I think that service mesh gives you a lot greater granularity and visibility into what's happening there, as our Hope 9 just pointed out, right? Each one of the services has its own TLS certificate, right? You can very granularly control those things. And I don't want to understate how valuable the metrics around the various services can be. And I say that particularly if you're working with an application, decomposing or what is it, the strangler pattern, right? With a monolithic application, it used to run on a server that had 800 cores and 97 terabytes of RAM, and now we're splitting it into containers and deploying this thing across Kubernetes, and it went from everything being local communication, on a single host. Now it's distributed across maybe dozens of hosts, in particular as it scales. So sometimes application components suddenly have latency where there wasn't latency before, and they have to take that into account. And things like that, observability can really make a difference for finding those gremlins, if you will.
Yeah, 100% agree. And so, Orwin, we have a couple questions coming in. So one of them is essentially, can you have like multi-cluster applications? So an app A runs in cluster 1 and 2. Does service mesh support multiple clusters, or an application running in multiple clusters? And then the other one is from Pete. Does the service mesh support the OpenShift virtualization?
Yeah, so the first question is around multi-cluster. So I have some slides. This is really later on. So the short answer is yes. We have kind of two options we support. So upstream Istio, for example, there's a bunch of, let's say, multi-cluster deployment options and topologies you could use to install. We have more this security first approach, and currently we have kind of two things. We have service mesh federation, as mentioned. This is the new feature with the latest version. So you have kind of distinct service meshes in one or multiple clusters, and then you can export and import services from one cluster to another. So this is an explicit configuration you have to do. And the communication is really, you don't need, the good thing is that the control plane, so the SUD control plane, doesn't need to access the other clusters Kubernetes API servers. So it's the whole communication and everything is through Ingress and Egress gateways, additionals that you have on both clusters. And this is the way you could use, for example, some failover scenarios for mirroring traffic in a staging environment. So, for example, you have a production cluster. Now you're developing a new version of a service, and you want to test it with production data, right? So you could, for example, federate the meshes and could export the mesh from the new service from your stage environment and import it into the production one. And then you could mirror the actual production data to this new service in the stage cluster. And you can test with production data if your service performs the right way, works the right way, and things like this. So federation is one thing. And the other thing is you can have also a multi-cluster installation, but with one control plane in one cluster. What we don't have is a single control plane outside for multiple clusters and multiple service meshes. So to, address this thing, I mean, it's on our agenda. it's a thing for the second half of this year or beginning next year. There are some efforts going on in the context of ACM, so Advanced Cluster Management, to have their kind of a central way to manage multiple service meshes in different clusters. So this is a roadmap item. And I think that was kind of the second question, right?
Yeah, well, so I can touch on the second question in just a moment from Peter. So our Hope 9 touched on something here that might be interesting in the context of what you just said, which is, Submariner, which is deployed and managed by ACM. So you have, 2 or more clusters that are managed by ACM and a cluster pool, and then you use Submariner to create essentially a federation across those, right, at the network level. So does Service Mesh and Submariner work together? Is like, would you have, say there's 3 clusters, would it be 3 distinct service meshes and the clusters are connected through Submariner, or would federation at the service mesh level be the better answer? Hopefully that made sense. I'm going to go with no, because you
I mean, the actual implementation with a Submariner or something, I'm not sure how it's gonna be done, right? So
okay.
Currently, so this is really this is something ongoing right now. There are plans to integrate it. I have no idea what technology and what network level the integration will be with ACM. So I can't answer this question, right? So now.
No worries. I jumped ahead on you.
Yeah, so currently it would be really the way to use federation. So
okay.
to have a multi-cluster scenario. This is what I would kind of recommend right now.
Okay. So I think, and I see Gaurav asking, I think it would be helpful if you have a demo that we could take a look at and see in action kind of what the capabilities are. And to jump back and answer Peter's question, Peter Lauterbach there. So yes, I believe as of OpenShift virtualization 4.9, if not for sure 4.10, virtual machines can connect to the service mesh. So if you have virtual machine-based application components that are communicating with container-based application components running in the OpenShift cluster with service mesh, it all works and it's all happy.
Right. So the demo thing, the question for me would be, should I directly start with a demo, or should we proceed? What is your opinion, especially the audience?
So we've got 10 minutes or so until the top of the hour. So I'll let you be the judge. I think we definitely want to spend a few minutes, looking at the demo, kind of digging into it and all of that. While he's saying, to get to the demo, I think Gaurav is thinking the same thing. So maybe we can, for a strange turn of phrase, kill two birds with one stone, right? And kind of discuss as we demo.
Okay, so I'm kind of afraid that you say we have 10 minutes.
No. So we have more than 10 minutes. I try to be cognizant of not going way far over.
No, sure. But I have prepared like 90 slides, and we're on slide 7, and that was not my plan. So this is what I wanted to say.
Yeah,
sure. Then let me do it this way. The demo I have to see it in action. So let us try to get the federation thing, what we've just briefly discussed here, right?
Okay. And welcome to the live stream, where nothing ever goes according to the plan that you had, and time is relative.
Yeah. So you see a lot of other things. So why do I need a service mesh? A difference to upstream Istio, OpenShift service mesh. So I've prepared much more. But we should have like a 3-hour session for all that. So let us jump to the service mesh across clusters. I just show you in 1 or 2 minutes some slides, just explaining briefly the concept, right? How the federation things work. So as mentioned, with upstream Istio, we have really multiple deployment options and so on for multi-network, single network, multi-primary, and so on. But normally what you need to use, there's no really a multi-tenancy out of the box there. At least I'm not sure with 1.13 of Istio. I think there's still nothing out of the box, but you need to have access with Istio to the other Kubernetes services. So our approach is, as mentioned, we have service mesh federation, where you have like distinct service meshes in one cluster or in different clusters, and you can enable sharing, sharing, and load balancing, and for specific failover scenarios, for example. And then also a multi-cluster service mesh, where you have one control plane currently. This is the way we have it right now, and we have a multi-tenant approach by default in OpenShift, so you don't even need privilege or escalated privileges to kind of install a service mesh. So you need a cluster admin to install the operator stuff, and the operator needs the privileges on behalf of the user to do the stuff, but the user doesn't need any escalated privileges. This is great in terms of security. So now coming to the federation topic. What we have is, if you want to federate service meshes, you can do that with 2.1 plus right now. And the way it works is you configure distinct service meshes, as mentioned, in one or different clusters, and the communications then through the Ingress and additional Egress gateways. And then exposing services to the other cluster is, so we have introduced additional custom resources for that. And you would specify an exported service set and also an imported service set, and then you can kind of use the services from the other cluster. So these are kind of in terms of the federation. The additional things we've done, there is a service mesh peer configuration, there is an exported and imported service set. This is what federation is then made up. So different ways to use the stuff. Let us jump to the demo. Let me check here. By the way, so if you have an OpenShift cluster and if you want to try exactly this setup, you could go to, let me see the repositories. Here is a GitHub repository, which is called Mesh Federation. So this Mesh Federation GitHub repo, you could just clone this one and then you're landing here. This is what I have. Here we have kind of the setup. What we want to do is we deploy now 2 service meshes, 2 different control planes. Just briefly, let's have a look at what's in there. So we have a production service mesh and we have a stage service mesh. And the first thing is we have a control plane. So this is the custom resource to deploy a tenant of a service mesh. And you specify do you want to have Kiali, Prometheus, what type of policy, telemetry, and so on. So this is a quite extensive custom resource. There are some complaints around it because this can be very complex. This is from an admin perspective, the way you would kind of upgrade your service mesh, you would add additional features, things like this. So this is kind of the central piece of your configuration. And what you see is we have an additional egress and an additional ingress for the other federation service mesh. So there needs to be a discovery port and so on. By the way, there's also an article I've written on this federation thing. You could probably have this link as well, and you could just follow the description here, and it should work. This is basically what we do right now. So a control plane. The next thing we need is a member role. So this defines in this control plane namespace what are the namespaces projects we want to include in our mesh. So we have one book info production namespace. Then we have a peering configuration to the stage mesh, where we configure like the address in this case, it's in the same cluster. So I will deploy both meshes in the same cluster and all the workload components. So this is the configuration. You need to configure the trust domain and so on. So some of the steps here, you need a root certificate of the other service mesh to validate the certificates. And then actually we deploy in the production mesh, this book info, which is the standard, let's say, demo for Istio service mesh, we deploy the complete book info in this production mesh. And then in the stage, we do pretty much the same thing. We deploy also a control plane. We configure the peering configuration and the member role. And here we only deploy kind of the new version of one of these book info services. This is our new one, and this is what we want to mirror the traffic from production to here, right? So this is the setup. Let's get started. So we just open a terminal.
Just for the record, all of this is fascinating to me because there's a bunch of different ways you can do this, right? I was the other day learning about Debezium and Kafka and effectively using Debezium in order to selectively extract records from a database to replicate into Kafka to then have, the non-production side of the application begin doing things. So it's fascinating to me to see all of the different ways that our app and development teams can accomplish this. I do want to jump back. I know we skipped over it. It was one of your topics that you wanted to cover, and that was resources or resource requirements for service mesh. Do you have like a 30 seconds, deploying X number of, instances of the proxies will consume, Y amount of resources or anything like that?
Yeah, just a second. What I'm doing, forget about this one. Don't have a look at this Docker command. So my Podman is currently not running. Sorry. So yeah, the thing is with Stream Editor CLI, it's not working as the way it works with Linux, So this is why I run the OpenShift Origin CLI container and deploy from there, because I'm running in the Mac environment. Andrew, I just a second. Let me just start the deploy process, and then we can just directly jump to the slides. There is something.
And it's okay if you want to. We can answer that question afterwards and include it in the blog post. So I figure that might be the easiest way to answer several of these by linking into. So we'll take the slides. We'll publish those to. SpeakerDeck. I think it's SpeakerDeck that we use now, and we'll link that in the slides and we'll in the blog post, and we'll answer all the questions and stuff that folks are asking.
So I've created a deployed script here. So all the components here should be deployed out of the box. And okay, I'm not logged in from here. Just a second.
And I'm not sure if you're intending to share the CLI or the terminal that you're using, or if you want to keep your browser up.
You don't see anything. Oh, Jesus. Okay, sorry.
I asked because sometimes I'm sharing a browser while doing something on the sides.
Okay, just a second. I'm sorry. I thought I've shared my complete screen, so I'm just okay. Just a second. Wow, this is not believable. Entire screen. So you haven't seen anything from my very cool custom resources so far, right? So here we are, right? So this is what I've mentioned. So here's, for example, the service mesh control plane configuration. So this is the Git repo, no? If you download it. So we have the control plane configuration, we have the member role, we have the peering config for the other mesh. We have the certificate part of it. And then this is the Istio virtual service mirror configuration then to mirror the traffic to stage environment. Here is the imported service set. So here we specify the services we want to import from the other mesh. And this is the other mesh, which is the stage one, which is very kind of the similar thing. But here we have kind of an exported service set, custom resource where we say, okay, we want to export this service that it's available in the production environment. And we only have this deployment here of the detailed service. So basically, this is what it is. Now, just a second. I'm not sure what was I'm in the container deploying the stuff. So let me just check the URL of my cluster here. Okay, what is so slow? That should be this one. Okay. So as mentioned, I'm in this I'm in this Docker container in the CLI. I've mounted this Git repository as volume in there. So I'm I'm just executing the deploy script from here now. And you see, okay, it's starting. So I'm creating the namespaces, the projects right here. This is, by the way, the deploy script. So we basically create the projects, we install the control planes. This takes some time until everything is up. We create the workload projects, then also the peering and member role configuration. We deploy the workload, get the certificates and all that stuff. And at the end, we should have everything up and running. So 2 meshes with a mirroring configuration and with federation configured in one cluster. So this is what we do. We wait a little bit. And in the meantime, let me go back to the slides. So what is the overhead was the question. Mm-hmm. So there's some data out there. You see it here. There's also the link to Istio where you can find this one. We also do some benchmarking, but you also find for the different versions of Istio, which also applies to our OpenShift service mesh, because this is kind of the foundation. We use Istio and additional things for observability like Chiali and Jaeger and Prometheus, Grafana, things like this. But you see that it will add, so this is the load test scenario with 1,000 servers and 2,000 sidecars running. And so the Envoy proxy consumes like a half virtual CPU and 50 megabyte of memory per 1,000 requests per second going through the proxy. Istio-D, the control plane, uses 1 virtual CPU in this scenario and 1.5 gigabyte of memory. And it adds 3 milliseconds to the 19th percentile latency. So, and there's some additional stuff. So things to consider also for the control plane is really the rate of deployment changes, the rate of config changes, which have to be propagated to all the proxies out there. The number of proxies, of course, out in the field. One very important thing in reality is always like by default, if you for example create a Istio configuration like virtual service, destination rule, things like this. So this translates to an Envoy proxy configuration, and by default this will be available in all proxies out there. But the reality is your services, they don't need to talk with every potentially available service in the mesh, right? If you have thousands of services, and this will increase really the memory and everything. So one of the things always to consider is where to expose the configuration. Is it really necessary to have the specific routing configuration on every proxy in your mesh, or where is it necessary? And you could limit things like this with a sidecar custom resource of Istio, for example. So this is very important in a production environment, for example.
It's like firewall rules. You don't want to have firewall rules that open everything to everyone. Rather, you want it to be selective. Right. And also, to be clear, that previous slide was referring to the Istio control plane, not the OpenShift control plane.
Exactly. Yes, things to consider for the data plane, and then there is also some, considerations regarding the latency, depending on the amount of client connections and the specific, let's say, telemetry you want to access. So in general, you can say you add like 3 to 7 milliseconds to each request in terms of latency. So if you have really very, very sensitive, latency sensitive applications, you have to consider if service mesh is the right thing in this case. It not always is, because there is a kind of overhead. Mm-hmm. For normal, let's say, microservice applications, it's not that much important in terms of latency. The resource consumption is something you will have to fine-tune for your specific, let's say, setup and the requirements you have. So normally, by the way, the feature which is really most often used, or why do customers use service mesh, is most of the time because not of the traffic routing things, it's most of the time the security thing, because you can lock down or implement an MTLS across the complete service mesh with thousands of services with one very small custom resource, for example. And you can really do really nice things to offload work from security-related things from developers and their services with very easy steps to do, right? So this is one of the top things why it is used.
And to be clear, you wouldn't want to turn the service mesh on and off, if you will. Like, hey, we think we're experiencing increased latency with this, a microservice. Let me turn on the service mesh. Let me connect it to the service mesh so I can collect a bunch of data and then disconnect it. That's it. I don't know how, either simple or complex, non-trivial the integrating with a service mesh is. That may be completely infeasible.
Yeah, right. So normally there is you have a service mesh. There's no way to just turn it off some way. You turn some features off probably, but you don't kind of have a feature switch to turn the complete service mesh on and off or something.
Yeah, our Hope 9, great for HIPAA traffic. Not good if you get DDoSed though.
So yeah, as far as I've seen here, so our deployment is done. So all the things are created, installation complete. You see, we could now query, for example, to see, okay, is there a connection between the meshes? So we can just go and say, okay, get a service mesh peer custom resource and see what the status is here, right? This is something we definitely could do. Okay, so let me open it here. So there's no JQ in the container. And the important things here is you see, okay, this is the status section of this peering configuration for the federation. And you see, okay, there is one for the remote. So the remote for incoming and outgoing connection. And you see, important is that both should be true. And you see, okay, both are true. So we have a connection. So this is from the stage mesh. From our staging environment view, we could check the same thing now from the production environment. But let us just check if our services are imported and exported. So we could also check now the imported service set in the stage mesh. From the stage mesh, you see, okay, there's an exported name. So this is the name under which the stage service is now exported, and this is the local service name. So this is the way I would address this imported service now in my production mesh. And this is what we use, for example, for the mirroring configuration. You see, there is not a cluster local service URI, so it is stage mesh imports in this case. There are also different ways how you could import services. You can import them as local. So there wouldn't be a difference. So for example, if you have a detailed service in your namespace locally running, and you would import it also with an alias of local, so the actual endpoints would add to your service. So you would have your when you address this local service URL, you would address your local service as well as load balancing to the remote host transparently. Right? So because the endpoints are just aggregated at the level.
Yeah, I like how it masks all of that complexity behind what is effectively a DNS entry, for the service. That makes it dramatically easier for me, a lowly admin, to understand.
Yeah. Okay. So you see, we have a prod mesh, we have the stage mesh. These are the things we have deployed. Let me switch to the admin view here. Okay. So Here is our production mesh environment. You see also here we can launch directly Kiali or Jaeger. So Kiali is our visualization of what we have here. So let us log in. Wrong somehow. So now we have Kiali. This is kind of a visualization. And I can see now, I can select namespaces in here. So prod mesh, prod book info. What I can do is, okay, let's see the applications we are here. What we have, display idle nodes. Currently, there is no traffic coming in, right? So no access. So all the things are idle. You see, we have a details service, we have a product page, we have ratings service, and a review service in different versions. So we could do canary deployments and routed traffic there. Workload services. Now let us just create some traffic, and to do so, just a second. That was the here. We need the URL of the Istio Ingress route. So let us just get the book info URL, and also then we just curl here in a loop. Every second we just access the product page. So now we should see in the graph of Kiali that some traffic is coming in. So at least this is currently updating every 15 seconds. We can also display request rates, response times, throughput, request durations. Let us add some things. Important is that we want to see the cluster boxes here and also the namespace. And you see that there is now some traffic coming in. Also display the security. So, okay, my browser is a bit slow. So what you see, we have a namespace, the production mesh, which is our control plane namespace. Here's our Ingress gateway. This is where our curl requests, so our actual things coming in. So we have a gateway configuration here, the things we've mentioned earlier. So there's a gateway configuration that allows traffic to this product page, to nothing else. So we can just access the product page. And now the product page, there is one workload, one version. This one will call the details service, and it will call the review service. And here we have a configuration. We have different versions of this review service, and we split like 1/3 of the traffic is going to version 1, version 2, version 3. And version 2 and 3, they are also accessing the rating service. Version 1 doesn't do it. And what we have configured here is a mirroring configuration. So for this detailed service, you see this icon means there's a virtual service applied to this actual service. And let's have a look into this virtual service. We should have a look here in the prod mesh. These are the Istio configurations we have currently in place. There should be, if the browser or something is working, we should see some of the virtual services. Hello, hello. Okay.
If you're anything like me, you've got like 800 tabs open at any point in time. So
it's not really working. Loading.
So I do like that previous graphic because I think it highlights a couple of important things. One, for me, it reinforces that we don't deploy service mesh or use service mesh in a vacuum, right? It's not the administrator decided to deploy service mesh so that they could get visibility into what's going on, or the application team simply went in and created a mesh and so that they can do it. It's definitely a joint thing. It's definitely the two teams have to work together to understand the requirements, to understand the impact to the cluster as a whole. Both to resources consumed, as we pointed out before, but also to the application itself. Hey, I'm going to be, as you're attempting to show here, right? I'm going to be replicating data from one to the other. That's going to, potentially increase the workload, more than you might expect by default type of thing. So it's one of those, like, I had some awareness, some knowledge that service mesh is one of those features that spans both sides of the street, if you will, or sides of the aisle, to use a U.S. politics reference. And this very much reinforces that. So Almost Christian on YouTube asks, can you auto inject sidecars in deployment configs? The deployments or the samples in the docs use deployment instead of deployment configs. And Peter, I haven't forgotten about your question. I see it too.
Yeah, you can of course inject also into deployment configs. The difference to upstream Istio is there is no namespace-based injection. You cannot label a namespace to like in upstream Istio, so you have to explicitly put the sidecar injection annotation to the deployment or deployment config to inject the sidecar. And the mesh namespace must be part of the service mesh domain, right? So it should work that way, right? So I'm a little bit confused. Not sure what is not working here, because
this is just it's part of live streaming. Something always has to go wrong.
Yes.
Johnny's the king of that.
I am. Yeah, I've learned like you've got to sacrifice a number of goats before you go and do live demos. I failed to do that in my last couple, so things have not gone well. So Orton, I'm sorry. There was another question earlier about API gateway integration. I know that we can use 3Scale with Istio, but like are some of the upstream API gateways like Kong or whatever the other ones are they supported with the Red Hat Service Mesh? Or maybe not supported in the sense of like.
So the only thing really supported currently is the 3Scale integration. There is a WebAssembly. That's the way you can extend the service mesh, the features of a service mesh with WASM or WebAssembly plugins. There is one for 3Scale currently, but there's nothing for Kong, at least nothing officially supported that I'm aware of.
Okay, yeah, and as I was saying, I was like, okay, supported in the sense of like it'll just work. Like we don't necessarily support Kong in their implementation, but we would support that integration.
Yeah, right.
Gotcha.
So Peter asked an interesting question a few minutes ago that I thought we might want to spend a minute on, which is, are there patterns or anti-patterns that typically apply or are conducive to using a service mesh? So Peter's specific question was, are there times where you think you need a service mesh, but really you shouldn't be using a service mesh?
Oh, I mean, this question is something you could spend really a day discussing. Probably one thing. I mean, there are a lot of things to consider, right? So one of the things, and this is also important, and I think this is kind of one aspect of this question, is what type of applications you see it here, right? So what type of applications are appropriate, so to say, for a service mesh. And so to kind of, looking there at the first step would be, for example, okay, microservice architecture. So we're talking about a service mesh. So obviously we need some kind of services, whatever it is, so to say. So now microservices, we have a bunch of, let's say, services communicating over a network in a synchronous fashion. This is perfect. This is kind of what it's made for. So for, let's say, typical microservices architecture, especially if it's pretty huge and you have a lot of services and a lot of inter-service communication. So this is really where it makes a lot of sense to have a service mesh. The other thing For example, what is with monolithic applications? So we only have like 2, 3, so very typical. If you think about Java, you have an application server type of application with, I mean, monolithic doesn't mean it's not modular or something. It's just from the aspect of you have like different development teams contributing the same code base, and you have more or less one deployment unit, right? So does it make sense if you have 2, 3 monolithic applications, some databases, things like this, some caching or message queuing? Yes, it could, but to be honest, service mesh doesn't add that much, right? So in this case, I would think you could, or you should think carefully about using a service mesh. What features do you want to have or want to apply? So security in terms of implementing it with a specific library or something might make more sense in this case, for example. So the reality is with monolithic applications, service mesh doesn't add that much. If you have a lot of communication between monolithic applications, okay, then it might. But yeah, think about it. What is with serverless applications, this type of thing? Yeah, I would say definitely in this case it makes sense. Why? Because serverless applications, and I'm talking now about OpenShift serverless, which is based on Knative. So we actually use also containers like everything else. It's basically just a different packaging format we have for serverless. And you can scale to 0, things like this. There is also an official integration with serverless, but the essential thing is here that serverless applications are actually microservices, even smaller most of the time. They serve for a specific purpose, right? So definitely with serverless it makes sense. With microservices it makes sense. Then I have some customers also asking what is with jobs, cron jobs, batch type of things, right? Processing. Yes, I would say it depends on the actual implementation of a job. What is this job doing? Is there some, communication involved where you need observability? Is there something involved where you need to secure the communication flow to because very often it's things like you start a job. The job is kind of grabbing something from a job queue. So there's an implementation in Kafka, whatever, a database where we grab some actual jobs or what a job should do, and then it's executing the job. Things like this. So it depends really on what the job is doing. And the problem with jobs is always we have the Sidecar container, the envoy thing. And so the job won't finish if we don't shut down this user proxy, right? So you need, and there are some workarounds, I know of them, but there's not really an official way, so to say, that we support jobs and cron jobs. So it's possible, and it depends on the workload, but not really the best kind of type of workload, I would say, right?
Yeah,
and then
Anon just highlighted the. Go ahead.
No, so sorry, don't want you to interrupt. So the thing is, yeah, okay, sorry.
Anon just highlighted the same thing that you were just saying around, the job status won't complete if the proxy sidecar is there, and
yeah.
So there's a number of questions that have come in, and for our audience, please go ahead and submit any questions that you happen to have. I do want to be a little bit cognizant of time because I think I have a meeting coming up here shortly. So I will get through as many of the questions as we can. Again, any that we can't answer here on the stream, we'll follow up in the blog post. We'll make sure we get all of those answered, including the slides that Ortwin has and all that other stuff. And Ortwin, you're very popular because we've had a couple of folks asking, like, can we have like more than one of these streams? Can we have like a mini series type of thing? So Stephanie, yes, I do care about your lunch hour. Stephanie's chatting me on the back end here. I do care about your lunch hour. I am obviously a very, we'll say healthy individual. I also like lunch myself.
Oh man,
Yeah, so just a couple other questions that we have here, and please everybody keep me honest. Will service mesh trust self-signed certificates applied to routes, OpenShift routes?
To OpenShift routes,
So if you're using the default CA, so if you're coming in on the route, it's going through the HA proxy over to the Envoy. Will that accept that self-signed cert?
yeah, it does. If not, it depends on the route config. If you kind of terminate at the route level, or if you kind of configure the route as pass through, then you would need to have the Istio from the Ingress gateway, the certificates for the client side, right? So, but in general, I would say yes, sure.
Okay, and then
and by the way, regarding just one thing to mention, because I'm also working on this topic. We know that, especially all these day 2 operation things in the context of service mesh, they are pretty much complex. There are a lot of different ways you could do things, right? Because there's so many options and so different types of requirements. And we also know that the documentation or kind of best practices on how to do things in especially from an operational side, that there is kind of also a, let's say, lack of documentation. And currently we're working on a service mesh day 2 cookbook, where we try to cover some of these things. So just for admins, for operators. So if you're planning, for example, implementing a service mesh, if you what are the things to consider if you want to head to production and things like this. This is just to make you aware there's something coming.
Yeah, or when you guys should do a service mesh coloring book. Or just turn it holding on its head and just do a comic book, just have like its own little like superhero thing. That'd be kind of cool. Go ahead. I've already given you permission to do it. You're good to go.
I pre-released this idea. So can the OpenShift service mesh be extended outside of OpenShift? For example, to include a virtual machine hosted in Rev, vSphere, or even a physical server?
Yeah, this is kind of, as far as I know, a roadmap item. So we can say, can you use OpenShift service mesh outside of OpenShift? The answer is no. So it is not supported outside. So the service mesh itself, this is based on OpenShift. So there is the dependency, but including like what we had before, like external bare metal machines, virtual machines, which are outside the mesh, outside OpenShift. This is something which is a roadmap item. And I don't know, Andrew, you said, I'm not really aware if this is already GA. I don't think so, but my current status, this is a roadmap item for the over next release. So for 2.3, which would be somewhere in I think June or something, so in the middle of the year. So answer would be yes, roadmap item, this is coming.
So not yet, but eventually.
Yeah.
Excuse me.
So there's another question from and I'm so sorry if I messed your name up, Sakrishna. And it was, how do you access an external service using the TLS origination from an egress gateway? So like once you set up an egress gateway in your mesh, how do you access that TLS endpoint?
Yeah, I mean, the way you would configure it is for external services. Normally you have, you create a service entry, right, to make this available to the Istio service registry. And then you configure a virtual service and a destination rule or two, where you kind of redirect the traffic to the egress gateway. And there you would configure in the destination rule the TLS config for the outgoing service then, right? So
Awesome.
this is something also documented on Istio side, and I'm not sure also on our side. Yeah.
And then I think the last question I see here, and apologies for any that we missed. We always go back and look at all the chat and everything to pick them up. But apologies for butchering your name, Elchin. Can we add a delay to the sidecar shutdown?
I'm not sure. I think you can with a annotation for envoy proxy, but I would have to look it up exactly. I think it is possible with an annotation. Not 100% sure.
Okay.
So,
I'm rarely 100% sure on anything, so.
yeah, right.
I'm 100% sure about that.
Yeah, I had a conversation the other day, and it was always, never, use always or never. Yeah. So, all right. Thank you very much, Ortwin. Really appreciate you joining today. This one has been a long time in the making, and it has certainly not disappointed from my perspective. I've learned a ton here. I expected to learn a lot, and I learned even more than I expected to. So, thank you so much. And I know.
Yeah, thank you for having me here. I mean, always happy to share something, and just to consider that was just 7 of my 90 slides I've prepared. Yeah? So there is probably some content for an additional session somewhere.
Yeah, just a little bit. Well, I know who we can reach out to whenever Johnny and I are struggling to come up with ideas or topics, right?
Okay.
So thank you so much for joining us today, Ortwin. Again, really appreciate it. I know our audience has appreciated it as well. There's been some folks who have been waiting for this one too.
Yeah, thank you, and thank the audience as well for all the questions and.
Yep. So for our audience, again, thank you for joining us. If you have any other questions that we didn't get to, if it was happened to be something we missed, for anybody who's not watching us live, you're watching a recording, please don't hesitate to reach out. You can contact me via email, andrew.sullivan@redhat.com. I'm also on social media, so Twitter @practicalandrew, just like you see on the screen there. On Reddit, on all of the platforms, all of the places you can find me. And Johnny as well, I will happily throw him under the bus for being a public contact. So I can, I always have to look at the screen to remember your Twitter username for some reason.
That's right, JRockTX.
You've been here for like 6 months, and I still have to look at it every single time. Because when I type it into Twitter, I just do @J, and it's you. And
that's right. Most important first.
Yeah, or Johnny @redhat.com, and that's no H, JONNY.
Yep, and I'm pretty active on the Reddit channel or the Reddit subreddits. So if you have questions out there, just go ahead and post them, and I'll try and reply.
Yep. So thank you, everybody. Please join us next week, where we'll be joined by the Microservice team, and then we're looking at some other topics a little bit further out. So things like OpenShift virtualization, maybe bringing back some VMware folks, so on and so forth. If you have any thoughts, ideas, suggestions, etc., please don't hesitate to send those our way. I can't talk all of a sudden. Please don't hesitate to send those our way as well. So with that, I'll leave the last word with you, Johnny.
Ortwin, thank you so much. Andrew, this is a great show.
Johnny died on us. Oh no.
I'm lost too.
You faded out. We lost you for like 10 seconds there. So I'm sure whatever you were saying was awesome.
All right, but yeah. So if you have if there's something that you want to see, then let us know, and we'll try and get a demo for you. Just let us know what you want to see, especially when it comes to the service mesh stuff, because there's so much, and like you can see, we barely even scraped the surface. So.
Yep. All right. Well, thank you so much, everyone. Have a great week and stay safe.
Bye-bye.